The paper of the day is Mostly Order Preserving Dictionaries. It's a 2019 paper. This paper introduces mostly order preserving dictionaries, MOP in short, for supporting efficient range queries on encoded datasets. They present a technique for generating a MOP with a limited sample of the input dataset while minimizing the size of the dictionary. In addition, they introduce a variation that uses cascading MOPs, CMOP in short, that has multiple levels of ordered keys. They present query rewriting rules to minimize decoding of keys to minimize predicate evaluation latency. Authors implement MOP and CMOP in the open source Columnar framework, Parquet, and evaluate query and generation performance. Their results demonstrate that MOPs are able to accelerate range filtering and sorting and achieve higher order ratios with small samples. The paper experiments use a real-world dataset of taxi rides from New York City, the line item table from TPCH benchmark, and two synthetic datasets derived from an English word dictionary based on uniform and Zipf distributions. Paper uses scale factor 30 for TPCH and 15 million rides from taxi dataset. Now let's look at the contributions of the paper. This paper presents a best effort order preserving dictionary encoding called MOP. It pre-allocates a code space for an order preserving dictionary based on estimated statistics such as record count and cardinality. A backup code space is reserved to handle potential code space conflicts, which paper explores both with unordered and cascading ordered variations. For distributed generation, MOP leverages a leader protocol to synchronize and update local directory views of its writers. For a MOP that has 90% of the keys ordered, they are able to reduce query filtering latency by up to 47% compared to decoding a standard dictionary, and 9% slower than an order preserving dictionary according to the experiments. In addition, paper proposes a nested MOP, cascade MOP or CMOP that minimizes the amount of disordered data at the cost of more complex query evaluation. Now let's give this paper a PS score. Overall, it's a very bumpy read with some super dense parts, so it gets 6 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. Reproducibility and repeatability might be challenging, so it gets 7 out of 10. Industry value and learning meter is decent, so it gets 7 out of 10 on each. Overall PS score is 7 out of 10.